Hello, and welcome to the SimScale tutorial on post-processing within the CFD environment. Today, we'll be looking at fluid flow through this pipe. We have two inlets, one here and one here, and a single outlet over here. So now let's dive into the post-processor and see how we can pull results from our simulation run. In order to access the post-processor, I'm going to expand my simulations runs here. Again, expand the run that I want to post-process, and open up my solution fields. For now, we have two options available, the new beta interface and the legacy interface. I recommend using the beta, and pretty soon it'll be the only option available. Now that I'm in the post processor, you can see it has a very similar workflow to the rest of the workbench. We have similar options up here, like changing the view mode, the render mode, and whether I'm selecting a volume or a face with a click. But here we start to see things change a bit. So over here, I can either change, in the case of a steady state simulation, between different iterations that I've printed out my solution for, or in the case of a transient simulation, through different time steps of the simulation that again, I have printed out my solutions for. And I can either do that by dragging the slider or using the arrows over here. I can also toggle on and off the legend as I prefer. Use the inspect point functionality. As you can see, I can just pick any point and read out whatever I am printing out on the simulation. And also toggle the bulk calculator, which works when selecting either a face or a volume, and will tell me again the integral and the surface area of whatever field that I'm again printing out on my simulation. I can also take pictures in the post processor in order to download them for later use or speed up future post-processing in the future. On to the legend, we have a couple options here. I can adjust the bounds by clicking on the edges of the legend, and I can also play with these little bottom sliders to play with the coloring. If I want to change the units, I can simply click on the units here and change to as units that is more suiting to whatever scale that I have involved here. And here I can also change what exactly I'm viewing. Let's say in this case I want to take a look at the velocity. If I right click on the legend, I get a couple more options. I can either scale to full range if I have been playing with the scaling. I can also use a continuous scale if I'm not a fan of the gradated results that we have here. If I do like the gradation, I can play with how many gradations I have. And we also have a variety of different color schemes to use if you would prefer something other than the traditional blue to red. Finally, I can also switch over to a logarithmic scaling if I so prefer. The basis of our post-processor works on filters. What does that mean? We have our base data set, which in this case is the pipe. But on top of that, I can apply various different filters, such as cutting planes, iso volumes, particle tracers. In order to access these filters, I will click the Add Filter button here, and I can select through which filter I would like to work with. Also, I can adjust the overall opacity of the model by playing with this opacity slider that you see here. Now, going through our filters, the first to look at is cutting plane. This one is, as you would expect, cuts the model along some plane. What controls do we have when working with the cutting plane? First of all, I can adjust the position of my plane, again through this slider, or via picking a point. And if I would like, I can expand the position toggle to put in an exact point across which I would like to slice my results. I can also change the orientation of my cut. For example, in this case, I might want to cut it along the x-axis in order to see the internals of the pipe flow a little bit better. I can invert the orientation of my cut. And similarly, again, I can expand the orientation tab to select an exact vector along which I would like to cut my model. Here I can control the coloring, similar to as before. In this case, now two legends show up because I'm printing out both pressure on the cutting plane, but on the overall bulk model, as you can see, I'm still printing out the velocity magnitude. And as soon as I switch that over to pressure, I will revert to having just a single legend. If I would like, I can print out vectors upon this cutting plane in order to better visualize the flow. Some controls that are nice here when it comes to the vectors. I personally like to either play with the coloring. In this case, I think black might be a bit tough, so maybe I'll switch it over to a white. You can also clamp the sizing of the vectors in order to shrink down the overall size or increase the minimum size as preferred. And I could control how densely packed they are via this grid spacing. The lower I bring it, the more vectors I'll get, and the higher, the more sparse they will be. The scale factor here I can use to either control how large the vector appears in relation to the velocity, or if I would like all vectors to be nearly uniform in size, I can bring that number down. Finally, I can also project my vectors onto the plane, meaning it'll only show me the velocity component which is projected on this plane of the velocity vector. We can also play with the opacity of the overall cutting plane as needed. I can choose whether or not I would like my cutting plane to actually clip the model, and this can be quite interesting when playing with opacities, for example. So I may make my overall model quite translucent, but leave it there just to give me an idea of the overall structure, but then keep my internal cutting planes as is, for example. I can show my mesh on the cutting plane if I would like to see the mesh internally. And I can choose to have a visualization of the plane itself if I prefer. In order to toggle on or off any filter, I can just simply toggle it on or off via the on-off button, and to delete it, I can just click on that trash can. Now on to our next filter. In this case, I'm just going to cover the ISO volume, as it is quite similar to the ISO surface, just with a small extra bell or whistle. The ISO volume will capture a volume of fluid that falls within a given range of whatever velocity or pressure or whatever scalar that I choose. So in this case, I find it quite useful to isolate things like areas of high pressure or maybe high turbulence. So in this case, I'm going to select the pressure, and here I can say, show me the pressure, the areas where the pressure falls between 600 and 1900, for example, PA. And now, as you can see, I have volumes that only show me those higher pressure regions. Again, quite powerful with having that translucent overall model in order to provide context. But now I can see, okay, clearly we have high pressure head before the T-junction, but also we're generating a little bit of pressure, probably some losses along these bends, as you would expect. Overall, the coloring controls are exactly the same as the cutting plane itself, so I can choose how I want to color this ISO volume. I can I can use multiple different scalars to color it. And I could also put on vectors onto the ISO volume itself or play with its opacity as needed. Finally, one of my favorite ways to visualize fluid flow is particle tracers. The particle trace filter is going to inject my simulation with a variety of particles, which will then follow the fluid flow trajectory. And this can be quite powerful for understanding how the fluid flow behaves. The first thing you have to do when setting up a particle trace is to select a seed point. I usually like to pick my inlets here. So I pick my inlets, and it's going to seed this inlet with a variety of particle traces, which then follow the fluid flow out to the outlet. I can control how many particles I have in each direction through the number of seeds toggle here. Again, I can also manually input as needed rather than just using the slider. I can also play with the spacing, meaning basically how tightly packed these different traces are. So usually I like to spread it out a touch depending on my needs. I can control the coloring, again, similarly to the cutting plane or the ISO volume, and how it's represented. By default, we use these cylinders here, but I personally like to use comets, as I think they give a very good idea of how the fluid flow is behaving. Finally, I can control the size, meaning how thick each comet or trace is, and again, in the case of the comet, I can control how long their tail is via this relative comet length. If I want, I can have it tracing in only a single direction, meaning it only follows upflow, or I can trace also it only follows the downflow, or I can trace in both directions and have it also go upflow as well. Now, I'm also going to add a quick particle trace up to this top inlet here. Again, switch it over to comets, and quickly show how I like to set up an animation to better understand my simulation. So in order to set up an animation, again, I'm going to add another filter and set up animation here. Now we have a couple options. Either I can choose to animate through my time steps. This is quite handy for a transient simulation, for example, when I have different time steps that I've printed out. Or in this case, I'm going to use particle trace because I'm looking at a steady state simulation and I just want to animate these particle tracers. I can control how many different frames my animation has here. The higher this number, the slower the comets will travel, but the smoother the overall animation will appear. Or I can speed things up, but have it maybe a little bit more chalky. And then I just hit play. And now, as you can see here, I get a very good idea of the overall fluid behavior through my system. As I can see, the particles flow in. We have some interaction here between the two fluid streams, pushing down the flow from this other stream here, and they exit out through the outlet. And that covers our tutorial for today. Thank you for your time, and happy post-processing. Bye-bye.